In the previous video, I had an array list of animal which consisted of different types of dogs and fish. Our abstract class had protected and private fields and 2 abstract methods, but an abstract class can also have concrete methods. Let's say I wanted a helper method on animal that printed out both the instance's class name and its type. Going to the animal class, I'll add that. Public string getExplicitType, return getClass.getSimpleName, and I'll print the type in parentheses. I've now got a concrete method on an abstract class with a body. Like any method on a parent class, that's a method we can use in subclasses. Going to the dog class, and I'll edit the move method. In both cases where I was printing out type, I can make a call to getExplicitType, which is the method this class inherits from animal. I also want to do that same thing on the fish class and its move method. I'll change type to a call to getExplicitType. Okay, so now I'm going to run this. You can see we have the simple class name dog or fish and the type of the dog or fish in parentheses. Your abstract class can provide concrete methods, as I showed here, that follow the same rules as a concrete classes method. Our subclasses can simply use them, as we did here, inheriting that behaviour from the parent. I could also override those methods. Let's just say animal is a strict parent indeed and doesn't want us to override this method. It likes this format and wants all classes to use it just the way it's written. Going back to the animal class, I'll add the modifier final. Convention has that being declared after the access modifier, public in this case. If I ran this code, the behaviour would be exactly the same. But if I went to our dog class and decided I wanted to create my own version of getExplicitType, I actually can't do it. I'll put my cursor before the closing brace of the class and press Ctrl-O. Notice it's not an option to override this method in the list shown there. But let's try anyway. At override, public string getExplicitType. Return an empty string. This is the standard syntax for overriding a method from the parent class. But look, we've got an error. If I hover over that, you can see that the overridden method is final, preventing us from overriding. I haven't really talked about the final keyword very much, but it simply means that for a method, a subclass can't override it. So the final method is final and cannot be overridden. This isn't specific to an abstract class, but I did want to show you how an abstract class can have both concrete and abstract methods. And the concrete methods can be designed so that the subclass can't change them. I will remove this method so that the code compiles. There are 2 other things I want to cover, and I showed this on earlier slides. First, I want to create another abstract class that extends animal. I will do that in the animal.java source file. Abstract class mammal extends animal. Here I am declaring an abstract class mammal that extends the abstract class animal. Now I'm getting an error on this class because of the constructor, so I'll include the constructor using code generation. Now this code compiles, but wait a minute, I wasn't forced to create implementations for the move and make noise methods like we were for the dog and fish class. Why not? Well, it turns out an abstract class that extends another abstract class has some flexibility. It can implement all of the parent's abstract methods, it can implement some of them, or it can implement none of them. It can also include additional abstract methods, which will force subclasses to implement both animals' abstract methods as well as mammals. Okay, so first, let's create a new class in the dev.lpa package, and I'll call it horse. And I'll have that extend mammal. And you see right away this doesn't compile. It's saying I have to implement move on animal, even though we're inheriting from mammal. This is because mammal didn't include an implementation for the move method. Let's add that on the mammal class. And now I'll just put something in there. I'll print out a call to getExplicitType, and also print the speed. First I print out the explicit type, and then for mammals, if the speed is slow, the code print walks, otherwise runs. I'm next going to add an abstract method specific for mammals, public abstract void shed hair. Don't forget the abstract modifier, and we follow that with a semicolon. This is the structure of an abstract method. And going back to horse, we still have that error, but it's specifying that now we need to implement the method shed hair on mammal. I'll implement all the methods remaining now. I still have an error on this class, but it's not because of overridden methods now, it's because of the missing constructor. So I'll pick Create Constructor Matching Super in that pop-up this time. Now the horse class is valid, but I'll actually put something in the shed hair method. I'll print out the type with a message. And for good measure, I want to create a horse in the main method. Animals.add, new horse passing Clydesdale, large, and 1000. Let's run this and review the output. You see that our horse is included in the output. But how would we call the shed hair method? Do you recall the instance of method I introduced you to earlier? I'll use it here. If animal instance of mammal current mammal. Current mammal.shedHair. So here, we know animal is an animal, but it could be a lot of things at this point, like dog, fish, or horse. But it could also be a type of mammal. You should always try to code generically so that when new subclasses are added, it won't be disruptive to your code. Here, I am using the pattern matching version of the instance of operator. I check if our loop variable animal is a mammal. If that's true, we'll get a mammal variable named current mammal, which gets assigned the loop element, but only if it's really a mammal subtype. Doing this means we can call any method on current mammal that's declared on the mammal abstract class in addition to the ones on animal. Let's run this now. You can see since horse is the only class that extends mammal, it prints out horse Clydesdale sheds in the spring. Notice what happens if we try to call shed hair on the animal variable. This code won't even compile. That's because animal is an animal type and the method shed hair is not on the animal class. I want to make one more change. I want to change dog to extend mammal instead of animal. Hopefully you're not surprised we get an error here. It's because mammal has that abstract method shed hair, but the dog class doesn't have a method for that, so I need to implement shed hair. I'll print out the type and then I'll concatenate a string. Every dog I've ever had pretty much shed hair all year long, so I'll put that there. Now running the code, you can see that for all our dogs, we're getting the output that they shed hair all the time. So that's an example of an abstract class extending another abstract class. This video is getting long now, so I won't cover the use case where we have an abstract class that extends a concrete class. It's a lot rarer to do something like that, but just be aware that that's an option. Let's finish this video with a question you might be asking: why use an abstract class? In truth, you may never need to use an abstract class in your design, but there are some good arguments for using them. An abstract class in your hierarchy forces the designers of subclasses to think about and create unique and targeted implementations for the abstracted methods. It may not always make sense to provide a default or inherited implementation of a particular method. An abstract class can't be instantiated, so if you're using abstract classes to design a framework for implementation, this is definitely an advantage. In our example, we don't really want people creating instances of animals or mammals. We use those classes to abstract behaviour at different classification levels. All animals have to implement the move and make noise methods, but only mammals needed to implement shed hair, as I demonstrated. Okay, so in the next video, I'll have an abstract classes challenge for you.